A very warm greetings to everyone. This is Suhasini, Assistant Professor, Department of Computer Science and Engineering, RMD Engineering College. In this lecture, we'll discuss about the subject Database Management System. And in the Database Management System, I'm going to discuss about the Relational Algebra. So what is relational algebra? How the relational algebra is related to DBMS is, we know we have some query language. DBMS will have some query language. We'll write such queries. So relational algebra will provide a procedure, which means a step-by-step process for to get the result from the query. So we are writing the query. To write a query, what are the steps? So it is called as procedural query language. So to provide this procedural query language, we will use the operators. So we have the 7 basic operators. Here it is 6, but it is 7 actually. So we have 7 basic operators. So they are select, project, union, intersection, set difference, Cartesian product, and rename. So each and every operators is having some symbols. So first for select it is sigma, for project it is pi, for union the union symbol, intersection symbol, for set difference it is minus, for Cartesian product it is into, and for rename it is rho. So we will see this is an diagrammatic representation for all the operators which is present in the relational algebra. We'll start with select operators. So before going to the select operator, we are going to discuss about all the different all the different operators with the example of these two tables. One is instructor table and the other one is the teachers table. So now we'll get into the operator. So first I have the select operation. So the select operators, how the select operator is, the word itself says, right? Select. If from a table, from a database, if I want some particular rows, okay, rows are nothing but the tuples here. So if I want to select some particular tuples, I have to process using this operators. So to select, I will be using just a minute. So to select, I'll be using this sigma operator. P, this is a notation of select operator. So sigma, the symbol, P is a predicate where you will give your condition, and R is a relation, is nothing but your table name. So where there in writing the query language will be telling select star from the table name, right? So here we'll say it as a relation. Relations are nothing but the table. To what table you want to do, okay, how you want to process. So with what condition, to which okay, I'm going to process some condition here, to which relation, which means to which tables you want to provide that particular condition. So I have an example here. So see, select those tuples. Here, as I said, tuples are nothing but the rows. So select those rows of the instructor relation. So I told in relation, instructor relation nothing but instructor table, where the instructor is in CSE department. So I want to go and check the instructor table here. I want to check which instructor belongs to CSE table. So by seeing this table, I can easily say, so the ID number, the person who is having the ID number 101 and the name is Anil belongs to the CSE. So I want only these row to be displayed. So for that I have to write a select operation command. So how I'll write that query? So sigma, the condition is my department should be CSE. So I'm writing it is in the base. So department is equal to CSE, and to relation means to which table I'm applying. So to the instructor table. So when I process this procedural query, I will get this result. So this is how this select operation will work. So coming to the select operation, we have other different methods for comparison. If you want to process the condition by applying the comparison, which means I've just get is equal to. So we can also process greater than, less than, greater than or equal to, or not equal to. Likewise, here I can process that also. So for that, find the instructor in easy with ID greater than 100. So for same, I am taking the instructor table. Here the ID should be greater than 100. If my ID is greater than 100, and also the instructor should belong to CSE department. When I go and select, first my condition is instructor should be ECE department. Yes, my the person, this particular row is belongs to ECE department, and also it should satisfy that ID should be greater than 100. Yes, the ID is greater than 100, which is 103. So I want this particular row to be displayed. So I have to write a query. What's that? So sigma department should be ECE and okay, this I have a and or a not symbol. So and ID should be greater than 100 in the relation called instructor. When I process this query, I'll get this result. Okay. So next, coming to this project operation. Project operation here is, so previously I was just selecting some particular, I want only the CSE department person, so entire has been displayed, right? So if suppose I want to appear some result, okay, some set of rows or attributes I want to display it. But when I go and use this project operator, what it will do is it will display what we want, and the remaining attributes will get deleted from the table. So for this the rotation is pi. This A1 to AK means what are the attributes you want from this table. So as I tell, A1, A2 to AK are the attributes and R is the relation name. So the main concept of this project operator, it will duplicate rows removed. The duplicate rows will be removed from result, which means whatever require, what attributes you want, that will be displayed, and all other rows and columns will be deleted. So coming to an example, here I have eliminate the department name attribute of the instructor. So I want to eliminate the department name. Okay. So how I'll process, I want to from this table I don't want this row. So what I will do, I will just select. Okay, I will not delete. Okay, you want to eliminate, but I will not delete. Instead what I'll do is I will just make sure that what I want, so that it automatically get deleted. So I want ID and name from the instructor, so remaining three will get deleted. That's it. Okay. So next, coming to the union operation, we are very familiar with this union. The meaning of union, it will combine two different relations. Okay, common relations. It will combine the two relations. So with the help of union, we'll just go with an example. So the rotation is R union S. It should be valid if R and S must be a same number of attributes. If it is same attributes, it will get displayed. So for example, here I am going, find the ID of instructor who teach second year or third year courses. Okay. So I want to display, okay, second year or third year persons. So from the teachers table, so I have the 101 is teaching second year, the 102 is teaching second year, the 102 is teaching third year. So what I am doing here is the duplicates has been removed. If I take to second year or third year, when I take second year also, this 1 or 2 is coming. When I take to third year also, 1 or 2 is coming. So with to this two rows, I will perform this union. So what I will get, so R1 will 101 will display and 102 will get displayed. So the query how I will write. So your project operation remaining cells should be deleted, right? So I am using this project operator. ID should be taken. Okay, only ID I want. Find the ID. So remaining things to be deleted, so that project operator to select that particular row. I'm performing select operator here. Select here is equal to 2 from teachers. Union, combine the same ID where year is equal to 3, so that I'm getting 101 and 102. Okay. Next is intersection. Intersection is in the same row two. If I find common things will be identified and displayed. So if they told or 2 or 3. Here I want the person who take second year as well as third year, which means I'll get identify the person who is common to second year and third year. It will not combine, it will just pick out that one particular row, right? So for that, R intersection yes symbol is here. So this is the same equation with symbol with a different symbol, intersection. Here they have to I have to find the ID of the instructor who teaches both second year and third year courses. So same condition with the intersection symbol. So I know that 1 or 2 is the common person who is taking second year and third year. So it got displayed, right? So next is set difference operation. Set difference operation is I want to find the tuples that are in one relation but not in the other relation. So how I will find R minus S. So it should be there in one but not in the third, which means the person should third only second year but not in the third year. If I do that, I cannot, if for with respect to this table 1 or 2, okay, 1 or 2 is a person who is taking second year but he is taking third year also. My condition is he should teach only second year, he should not teach third year. So I have to minus, right? So I want to reduce that. So my year ID, the person should teach second year but not third year. So second year minus third year, I am putting this condition. If I get that, only 101 is teaching second year and is not teaching third year or any other years. So I will get only 101 ID. So with the help of this project operator, remaining things are getting deleted. So Cartesian product. Cartesian product is nothing but you are going to perform, you are going to multiply the two different tables and you are going to provide a combined table. So how this is going to happen is, I want this ID into ID and ID is going to be this instructor ID is equal to teacher's ID. I want to perform that. Both the IDs should be same. So when I multiply instructor into teachers, how it get multiplied? So I take instructor table 101 is getting multiplied with 101, 101 is multiplied with 102, 101 is multiplied with 102 again, 101 is multiplied with 104 again. Okay, so next is I am going to perform, okay, next is I am going to perform 102 with 101, 102 with 102, 102 with 102, 102 with 104. Likewise, I'll multiply all the different combination and I'm getting the one table. So next is rename. Rename is nothing but I have a table. I want to rename the name of the table and the name attributes of the table also has to be changed. In such cases, I will go for the rename operator. How I will rename it? So notation is row and you have what attributes you want to change with the student. I mean the table, what is X is the table name and what attributes you want to change and the expression, okay, to which you want to apply, okay, to which expression you want to, I mean to which table you want to apply. So this whatever you are giving next to the row, it is a new element, okay, and this expression is already present, okay. So student, I have to change the table as student and the attributes are roll number, S name and department. So where these things, student, S number, serial number, department will get deleted if the condition of the instructor from the instructor. Okay, this is how my rename operation works. Okay, thank you.